In this tutorial, I want to show you one of the really handy features in Phi that makes it easy to swap the values of two or more variables. You can also do it in C, but it takes a little bit more work. Swapping the values for two variables is something that is done fairly often in programming. I will show you how to do it in C and in Phi in a side-by-side comparison. On the left is the C version. We have two local variables that I've named A and B. Their type is unsigned short. The variable called A I initialize with a value of 1, and the variable called B I initialize with a value of 2. To show us that the program is working properly, I print both values before I do the swap, and then again after I do the swap using calls to printf. These three statements here in between the two calls to printf is where the swap is done. In C, we need a temporary variable I have called t that is short for temporary. In this first statement, we have to store the initial value of A before we overwrite it with B's value. If we didn't do that, the value would be lost and we would end up with both variables with the same value. Once the initial value of A has been safely put away in T, then we can overwrite A with the initial value of B. Now, since we have A's initial value saved in T, we can then store it to B. When we run our program, this is the result. On the right side, we have the Phi source code. It has the same functionality, but of course the code looks different. The double dagger on the main function marks it for export, and we can see that there is no return value as it is marked with the void symbol. The single dagger on printf marks it for import, and it also returns nothing. The first argument is a pointer to unsigned single byte. The trailing comma in the argument list means that additional arguments may follow. The next thing to notice is that the unsigned short type we have in the C version is UD in Phi. This stands for unsigned double byte. The most important thing to notice here is that there is no temporary variable named t. This is because it is not needed. While we still are using the same printf function in the standard C library used in the C version, in the Phi version we have to apply this UTF-32 to UTF-8 text array to byte stream operator to produce an argument that is palatable to the printf function. Now, looking at this one line here in between the two calls to printf, it is where all the action takes place. As in C, the left assignment operators work from right to left. We see that the first assignment to be executed is this one on the right. It is the read before write left assignment operator. It first reads B's value before overwriting it with A's value. It is B's initial value that is returned from this assignment operator. This is then assigned to A using the left overwrite assignment operator. When we run the program, we see that it accomplishes the same thing with less code. Out of curiosity, I compared the sizes of the two programs and they were not the same. The C version was 43.415K, while the Phi version was only 43.057K. I can't explain why the Phi version ended up being smaller. Many years went by while wishing I could do this sort of thing as a C and C++ programmer. Phi is pretty cool, but this is only one of the many things that puts Phi in a class all by itself.